nongeye kuba ikaze muri toza ishuri TV. Uyu ni umwanya tugiye kurikirana isomo rya electronic. Aba ndi kumwe na teacher Bernard, akaba rugiye kuba batugezaho isomo yaduteguriye uyu munsi. Ngiye guha ikaze teacher Bernard abanze asuhuze abadukurikiye mwese.
Twongeye kubasuhuza abadukurikiye kuri ishuri TV. Nitwa Bernard Sengiyaremye, rigiriye bagezeho isomo rya Basic Electronic uyu munsi. Tubasuhuza by'umwihariko turasuhuza Technicien Tarsis ku isoko i Butare, Technicien Jari, mwese mugubwe neza kandi mukomeze gukurikira amasomo ya ishuri TV. Turakomeza mu kanya.
Nimujye kure ni mu kanya na teacher Bernard abagezaho amasomo yaduteguriye kuri uyu munsi. Ciao.
Twongeye kubaha ikaze muri studio za ishuri TV. Uyu ni umwanya tubagezaho isomo rya electronic muri Basic Electronics, aho uyu munsi turi bubigishe ibijyanye na two types of electronic components. Electronic component has two main types, passive component and active component. Passive components are those components which does not require external sources to their operation. Example of passive components are resistor, capacitor, relay switch, and so on. As these components we mentioned above they does not require external sources to their operation. For each, we will see how to make calculation, how to measure them by using a multimeter, how to make their circuit diagram, and how to calculate them. Passive components are those components which require external sources to their operation. These are active components. The example of active, these are transistor, diode, especially are these semiconductors. Let's back to passive components. Here they are showing us resistor as the first example we saw above. Here they say resistor is passive two-terminal electrical component that implements electrical resistance as circuit element. Then resistor are common element of electrical network and electronic circuit are application in electronic equipment. Practical resistor discrete components. Ahangaha baradusobanurira resistance ko ari component iri passive electronic nkuko twabibonye hejuru, ifite pin ebyiri cyangwa two terminals, bakatubwira n'uburyo ikoreshwa. Resistor connection, agace dukurikiye ijeho nkuko twabivuze haruguru ko turi burebe connections of every or connection of each component in passive and active components. Here resistor connection, in resistor connection we have three main connection, where the first connection is series connection. Series connection, the resistor, here they show us the example of resistor connected in series, where the first pin of one resistor is connected to the next pin of the next resistor. Here you see resistor 1, resistor 2 with a third resistor. Then for how to calculate the total resistor which are connected in series, you have to write first resistor plus second resistor plus third resistor as it is. Then resistor in series, here they are making in summary, they say to summarize, when two or more resistors are connected together and end to end in a single branch, the resistors are said to be connected together in series. Resistors in series carry the same current, different voltage drop across each resistor as determined by Ohm's law. This is Ohm's law, where voltage is current times resistor. You have to know the Ohm's law. This formula will help you to understand resistor connection in Ohm's law. Then series circuit are voltage divider that we will see in the next connection or the next details about resistor connection in series. Then the second type of connection, resistor connection, is parallel connection. Parallel connection, you see the circuit here where the formula of how to calculate resistor in parallel is different to resistor connected in series. You see the formula here, 1 over R total equal to 1 over R1 plus 1 over R2. You see? Then this formula it helps us to understanding well how to make a total resistor while our connection is in parallel connection. Then the third connection of resistor connection is mixed. Mixed connection is when our connection we have resistor which are connected in series and one which are connected in parallel. Is when we say you have mixed, because you have both series and parallel connection. Here you see example of these circuits which are connected in mixed. Here you see resistor 1 is series with resistor 3, then resistor 3 is series with 8 resistor but is parallel with resistor 2, and here we will see well how to make total resistance by using the formula of resistor we saw above. In mixed connection, for calculating total resistance, you have to make those resistors which are connected in series, make total of them. As we saw, the formula is to make the sum of all resistor. Example we saw that is to, let's back to series connection. We saw that is to make resistor total is equal to resistor 1 plus resistor, the resistor 1 plus resistor 2 plus third resistor is how to make a total resistance. Then in parallel we saw that is 1 over R total equal to 1 over R1 plus 1 over R2. Then the total resistance in parallel equal to this formula is equal to resistor 1 times resistor 2 over resistor 1 plus resistor 2. This is how to make a sum or total resistance in parallel connection. Then, after looking about parallel and series, then we are going to see how to make a total resistance while we have a mixed connection. Then here you will take R total of resistors which are connected in series, and you have to add total of resistors which are connected in parallel. Here we are going to show you simple example. Tugiye kubereka uburyo wakora total resistance in mixed connection. You have to follow how we are going to make this formula. Resistor in series. We saw that you have to write first resistor with, this is R1, R2. Then here we saw that R total is equal to R1 plus R2. Then we have to remind you that the unit of resistor is ohm. Then in parallel, are connected like this. This is R1, R2. Then R total is equal to 1 over R total is equal to 1 over R1 plus 1 over R2. Then R total is equal to R1 times R2 over R1 plus R2. Then after looking resistor in series, how to make total resistor, and how in parallel, now we are going to see how to make total resistance in mixed connection. Then in mixed connection example, we have two resistors in series connected with other resistor in parallel. Then this is R1, R2, R3, R4. Then in this circuit, as you saw, it has series connection and parallel connection. Then to make total resistor, you have to calculate resistor which are connected in series, resistor in series, total resistor in series plus total resistor in parallel. Then here we have R1 plus R2 which are connected in series. Example, if here we have 5 ohms, then R2 is 5 ohms too, R3 is 10 ohm, then R4 is maybe 5 ohms. Example, here resistor connected in series will be calculated like 5 plus 5 which is equal to 10 ohm. Then parallel total resistor is, we saw that is R3 times R4 over R3 plus R4. Then here we will see that is 10 times 5 over 10 plus 5. Here we will show that is 50 over 15 ohms. Then total resistor of the whole circuit is total resistor in series. We saw that is 10 ohm plus 50 over 15 ohms. This is the total resistor in mixed connection. Then after studying resistor connection, here we have example, or we have a circuit. I'm asking you who are watching this video, how many connections are in this circuit, and how can we make total resistance of them. Example of this: first resistor have 2 ohms, second have 5 ohms, third resistor has 5 ohms, fourth resistor has 6 ohms, and R5 has 10 ohms. Then we are going to see how to calculate this total resistor. In this whole circuit, you have both three connections we saw. We have series connection and we have parallel connection. Then we will see how to make calculation of total resistor. Then here we saw that we make a sum of resistor in series. We have to make R1 plus R2, which is equal to 2 plus 5 equal to 7 ohms. Then this series connection also we are going to make its total R3 plus R4, which is equal to 5 plus 6, which is equal to 11 ohms. Then now we make another circuit which can be drawn like this. We have one resistor. This is 7 ohms. This is 11 ohms. This is 10 ohms. Then we still have both mixed connection. Then these resistors are in parallel. We have to make the R total, which is equal to 7. Let's use its equivalent. 7 times 11 over 7 plus 11, which is equal to 77 ohms over 18 ohms. Then now at this stage we have another circuit which is like this. This means no, this is not a kind of resistor. Resistor is drawn like this. Then at this stage we have this kind of circuit which is series. Then this is 77 ohms over 18 ohms. This is 10 ohms. Then the R total, which is a final, is equal to, because it is in series, you remember in series we have to make only addition. Then here we have 77 over 18 ohms plus 10 ohms, which is equal to total resistor of our circuit. So, thank you for watching this lesson. Turabararikira gukomeza gukurikira amasomo yacu azajya acaho uko tuyashyizeho, tubibutsa gukora like, share na subscribe kugira ngo mujye muyabonera ku gihe. Murakoze.